Logical to do 2 next. We got 2, -3, -2, 3. Not give away one of my secrets. Okay, so I got factors of 3 and 1 over 2 and 1. So that's going to give me 3 halves, ew, 1 1/2, and -1/2, and -1, and -3 halves, and -3. Well, that's fun and entertaining. All right, let's get this rolling. I'm going to start with 1. Why? Because I'm lazy. Put a 2 down here. I get 2. I get -1. I get -1. I get -3. I get -3. I get 0. I already found 1. That's good news. Who knew? Dre, are you okay?
Oh, yeah.
All right. I'm going to have to do a half. Why am I going to do a half? Remember, it's factors of the last one divided by factors of the first one, right? That's a 2 out there, so that's 2 and 1, which means 3 divided by 2 is one of the ones I have to check. And 1 divided by 2 is another one I have to check, right? So now I'm going to do some more guessing. Let's guess -1. I like -1. That gives me -5, gives me 5, which gives me 3. -3 gives me 0. Oh, man. I'm on fire. Just need one more. One more. Wouldn't it be nice to know where that one more is? I know where it is. Do you know where it is? What? I know at least half of these are wrong answers. How do I know that? There's something called Descartes' rule of signs. Descartes' rule of signs. It sounds like it would be really hard to do, and it sounds like it would make your life miserable, and it sounds like really big math, but it's the easiest thing you've ever done in your life. Are you ready? Ms. V, are you ready now? Okay. Did I change signs? 1. Did I change signs? Did I change signs? 2. There's 2 positive answers and 1 negative. Because I changed signs twice. There's only 2 positive. There's a maximum of 2 positive answers and a maximum of 1 negative answer. Why is that important? I already found my 1 negative one. I'm not going to look down there anymore. I'm done looking down there. Now, Descartes' rule of signs works on the fact that if you place a coefficient in front, it can drive the function up and down, right? The more it changes, the more positive numbers can be answers. The less it changes, the more you need negative numbers to fix your problem. More importantly, now I can make a better guess because I'm not looking below this line anymore. It's not going to be there. Are we ready? Let's go find the last one. 3. Why? Because I'm lazy. 6 gives me 3, gives me 9, gives me 7, gives me 21, 24. That was a bad choice. Half or 3 halves? Which one's better? I'm going to go a half because that's probably wrong. 2, a half becomes 1, then becomes -2, becomes -1, becomes -3, gives me -3 halves, which would be 1 and 1/2. That's not a good answer. Bummer. Let's try 3 halves. 2 gives me 3, which gives me 0. 0 times 3 halves gives me -2. -2 gives me -3, which gives me 0. Ka-ching! So my answers are x equals 3 halves, 1, and -1. Those are my rational roots. Okay? So the first thing we have for looking is intermediate value theorem, which is a fancy word for saying you got to have a 0 between positive numbers and negative numbers. The second thing you're going to use is this idea of Descartes' rule of signs. You can count how many positive answers, how many negative answers are possible. Okay, now don't do 3 next. Skip it and go to 4. If you do 3 next, you're on your own because I get to laugh at you because it's really awful. I want to give you all the tricks before you do 3 because it's still going to be awful. Yes, ma'am? Oh. Factors of the first one divided by factors of the last one. Sorry, I just said that completely backwards. Factors of the last one divided by factors of the first one, right? So what are the factors of 3? 3 and 1. All right, 3 and 1 up here with a little comma on top just for my notation. This is bad math over here, but I just going to do it. Factors of 2. 2 and 1, right? And then I take every combination, right? 3 divided by 1, that's 3. 3 divided by 2, that's 3 halves. 1 divided by 2, that's 1 half. 1 divided by 1, that's 1. And then I have to have the same one's negative because you can make negative factors as well. That's a list of all the possible answers. It's a rational root theorem, right? All it has to be one, the front, ones in the back divided by ones in the front. So Mr. Hagee gave us. Okay. All right, working on 4. Pausing. Go back to my factor 1. And then 1 sign change, 2 sign change, so 2 positive, 2 negatives. That's unfortunate because it doesn't narrow down my field much. Anyways, I'm going to start with 1. 2. Oh my goodness. I didn't mean to do that again. I'm on a roll. You should have to do like all of them, because even with my tricks, like, oh yeah. Guessed wrong again. Now, why am I going to stop guessing positive numbers? I got my 2 positives. I'm now going to look at negative land, right? So negative land. Now, one of the tricks you also should be aware of is oftentimes they mirror image across. I don't think this one does, but oftentimes they mirror across. So a good guess would be -5. A good guess would be -1. Since -1 is easier for me to guess, I'm going to guess -1 as a starting point. -1, -4 gives me 4, which gives me -7, which gives me 7, which gives me 10, which gives me that. But that one mirror image. Hope you said oh. All right, I'm going to check -5. 1 -5 gives me -8. That gives me 40, which gives me 29. Now I'm going to pause here a moment. Is there any chance this is going well for me? No. Should I keep bothering with it? I mean, I may have to go back and finish this one just in case, but sure looks to me like that's going to a bad place and in a hurry, right? So I'm going to back up. I'm going to try -2. -2 gives me -5, gives me 10, gives me -1, gives me 2, which gives me 5. -10 gives me 0. Thank goodness I didn't bother finishing -5. So my answers are x equals 5, 1, -1, and -2. Remember, that means that the factors of this thing are x minus 5, x minus 1, x plus 1, and x plus 2. If you FOIL this together, you get that ugly thing.
If this were to be on a test, you want to grade the
I'm going to tell you what answers I want. I'm reminding you of the facts. Here's the one truth. When I do this problem for years and years, I just did this over and over again. And people forgot they were finding the factors as well. And so at the very end of the chapter, I'm going to say, hey, and you can find the factors. And it's like, so I'm trying to remind you that we can do both with this tool. I'm going to keep trying to remind you so I don't mess up at the end of the chapter and say, surprise, we need to be able to factor these things. And then it's like, well, when did we learn that? It's, yes, last class period we learned that. And this class period we're reinforcing it. We got it. Solwyn's bored. I'm sorry, Solwyn. You're just tired? How can you be tired? It's Friday. You get this April break behind you. You're like, this is going to be great. You get all this chance to study and do work on my own. I'm going to Google trig pre-calc videos in my spare time. Watch a little extra. Yeah. I know. I got the last trick for you. Last trick's right here. That's this. I'm going to put in 3 here. 3, 9 gives me 10. 30 gives me 22. That gives me 66, which is 72-ish, I think. That okay there, everybody? Okay. Mr. Riggy, earlier you winced when we got to a certain point, like I was going to pick bigger and bigger numbers and it's going to go awful. How did you know that? It was going to get awful, right? You were looking at it going, you and I shared a glance. You're like, okay, we're going to stop doing this problem here. We're going to move up one and see if we can do better. How'd you know that? The numbers are getting bigger. When you have a positive sitting here, and I'm multiplying positive numbers by each time, and it's getting bigger, guess what? It's not going to give you 0. There's a theorem. Some mathematician gets credit for this. We say, oh, he's brilliant. He came up with a theorem for which we discovered that he can actually, it's getting ugly. The getting ugly theory is actually called the upper bound theorem. It means this. If all of these are positive in positive land, if all these are positive, that means don't look up here anymore because it's not going to be here. This is called the upper bound theorem. Okay? Upper bound theorem. If they're all the same sign, they're all positive, they're all negative, don't bother looking above that point. You're never going to find it. Okay? All right. Let's try one down here. Let's try -3. Ready? 3. -9 gives me -8. Negative gives me positive 24, which is positive 16, which gives me -48, which is -42. Isn't that getting more awful too? So on the lower bound, it's not all positive. What is the pattern? It's alternating, right? It's going from positive to negative to positive to negative. That happens because this negative is driving the whole thing now. It's too powerful for the numbers I have up here, which means you're already below the point where an answer could possibly be. So this is going to be called a lower bound. And don't check below it. So if it's the same sign on top, that's an upper bound, don't check above it. If it's alternating signs, don't check below it. Okay? It's not going to be there. Okay? Now that's only true for negative numbers and positive numbers, right? When you're checking for positive numbers, if you get an alternating here, that doesn't necessarily mean you have a lower bound. If you get all the same numbers down here, that does not mean you have an upper bound. Okay? All right, from there you can finish this problem off. Bell's going to ring in a moment. So what I'd like you to do is finish the problems on this one. Yes, I give you dreaded number 3 to do at home. That's going to be great for you. And then I want you to do problems number 9 and 10 on the new worksheet. It's the same stuff. In fact, it was the same worksheet until I chopped it up. Okay? That gives you 4 problems to do in a week. Finish the problems on both these worksheets, right? So you have 2 more here. You cross that one out, and then you have 2 more here. Don't roll your eyes. It's 4 problems in a week.
What problem?
There's no good teacher in America giving you 4 problems in a week.
Yeah, there is.
Okay, solid. How many problems do you guys take home for homework like an average day down at Galena?
0. Actually, not that much.
Not that much, huh? All right, step to my point. Sorry, buddy.
Well, I was dumb since substitution.
You were dumb since education in class?
No, I was with them.
You're
So
with
I
them?
would have to
How do dumb kids in trip? It's not possible.
I have no idea. I feel like trade Galena was way easier.
That's great.
Because
I pushed the kids pretty hard. Although, to be truthful, you walked in with the worst 2 chapters, regardless of which.
That's true. That's where I can't tell you. But I did get like a 90% like
Damn.
and then I think we got over
I got crushed on the first test. Like, wait, what's going to happen? That part of that might be that first. Everything else
It's called.
what the biggest protest of the new curriculum is curriculum. I'm just trying to say that the worst possible chapter. What are we doing?
Everybody's getting suspended.
Yeah.
Beam them, dude.
Writing up.
After school, they're
Oh,
all
I'm
trying
sure
to have
it's
after school. I'm totally happy doing that for you, but then